Hello everyone. In my previous video I told you about the Cohen-Sutherland algorithm which is used for line clipping, and in this video I will be discussing about another line clipping algorithm, that is the CYRUS BECK line clipping algorithm. Now this algorithm is more efficient than the Cohen-Sutherland line clipping algorithm because it involves simpler calculations like dot product, and also it deals with parametric line representation. Okay, so that will make the calculations more easier and less complex. So let's see. Now first of all, let's draw the window. If this is the rectangular window, then we have this line, okay, and it's named as P0, P1. Okay, now the parametric representation of this line is P of t equals to P0 plus t into P1 minus P0. Okay, where t is the parameter. We will find out the value of t later. Before that, let's understand the algorithm. Okay, now according to the algorithm, if this is edge E of the rectangular window, then there is a normal drawn to this edge E and is named as N, and as you know, normal means it is perpendicular to the edge E. Okay, so a normal is drawn to the edge E and 4 points are selected at random. Okay, the first one that is selected on the edge E, that is, let's say here, and we name it as PE. The second point is selected on the line P0, P1 but outside the window. Let's say it's here and we name it as A. Okay. The second point is at the intersection of the line and the rectangular window, which will be here, and we name it as B. And the final point we select on the line P0, P1 but inside the window, so that will be here and we name it as C. Now what we will do, we will draw distance vectors from PE point to all the 3 points on the line individually. So first one is here, then we have here, and finally we have here. Okay, so this is the point PE, this is the vector from PE to C. So done. Now what we will do, we will perform the dot product operation between the n and the distance vector. Okay, so that is n dot pt minus pe. Okay, so we are performing the dot product between the normal and the distance vector. Now this is equal to mod of n and mod of pt minus pe, then cos theta. So this is the expansion of dot product, that is the value of the normal and the value of the distance vector multiplied by cos theta. Okay, Now for the point B, which is at the intersection of the line and the rectangular window, for that point, so for B we have theta equals to 90 degree. Okay, for B we have theta equals to 90 degree because the vector is coming this side and we have the normal moving perpendicular to the vector. So that means we have theta 90 degree. That means this, the value of the dot product will be, so dot product will have value equal to 0. Okay, now as the dot product value is 0, that means it implies that B is on the boundary. Okay, so this implies B is on the boundary of the rectangular window. Now we have for C. For C, theta is greater than 90 degree. Okay, that means dot product will be less than 0, and that will imply that C is inside the boundary. Okay, so if dot product is less than 0, that will imply the point is inside the boundary of the window. And then we have the final case, that is when, that is for A. For A, theta is less than 90 degree. Why? Because the direction of this vector and the normal is same, so theta will be less than 90 degree, and that means dot product will be greater than 0. So that will imply A is outside the boundary. Okay, so this will imply that if dot product is greater than 0, that will imply the point is outside the boundary. Okay, so these are the three conditions that will determine which parts of the line or which portions of the line to be clipped. Okay, now we can derive or find the value of T, that is the parameter. Okay, so let's start doing that. Now, for calculating the value of T, we will consider the point B, that is the intersection point. Okay, now at the intersection point, N dot PT minus PE is 0. Okay, so I will just put the value of PT here. So N is P0 plus T into P1 minus P0 minus PE equal to 0. I will apply the associative rule and multiply or perform the dot product with each of the terms separately. So N into P0 minus PE plus N into T P1 minus P0. Okay, now I will consider P1 minus P0 as D. Okay, so I will replace it, so that makes N dot P0 minus PE plus N dot T into D, that is equal to 0. Now I will take this term on the right hand side, so that will make minus N dot TD equals to N dot P0 minus PE, and from this we can calculate T equals to N dot P0 minus PE divided by minus N dot D. Okay, so this is the value of T. Now the value of T will maintain three conditions. Okay, the first one being N not equals to 0. The value of the normal vector will not be 0, because if it becomes 0 that might cause error. Okay, the second condition is D is not equal to 0, that is P1 not equals to P0. Okay, now if P1 equals to P0, then that will make a point and not a line, and since we are dealing with line clipping, therefore we don't require a point, we require a line. So for a line, P1 can't be equal to P0, P1 not equals to P0. Okay, now the third and the final condition is N dot D not equals to 0. Okay, which means that the line P0 P1 can't be parallel to the edge E. Okay, now if the line becomes parallel to the edge E, either it will remain outside the boundary or it will remain completely inside the boundary. Therefore there is no question about clipping, so that can't be allowed. So N dot D can't be equal to 0. Okay, so also if N dot D becomes 0, then the value of T will not be in between 0 and 1, but the value of T must lie between 0 and 1. Okay, so for that we can't allow the dot product between N and D to be 0. Okay, so this was all about the CYRUS BECK line clipping algorithm. Stay tuned to my channel for my next videos, and in my next video I will be dealing with you about the Sutherland-Hodgman polygon clipping algorithm. Okay, that will be the last video on the computer graphics course. After that I will move on to the operating systems course. Okay, so do subscribe to my channel to get notified about the videos that I upload, and like the videos and share them with your friends, and do support my channel. Thank you.